Okay, so hello, this is AQA Pure Core 1, Summer 2010, question 1. So the question is about a trapezium. It's the algebra part of the specification, so don't worry about differentiation. You'll only make the kind of question more difficult for yourself if you start differentiating things. Um, and yeah, I'm not going to have the questions as I'm answering them, so it's probably best if you open in a separate page the question sheet. I'll link it in the description box below, and this question paper and mark scheme. So let's not waste time. Question, well, to start with, I'll just draw it's based on a trapezium. Oh, that's not a very straight line, sorry. Y to the sky, X. So the trapezium is kind of like this, and it's A, B, D, C. Lovely, that's a rubbish drawing. Okay, so 2x plus 3y equals 14, and you're given that as being the equation of the line AB. So you're also told that DC is parallel to AB. They are parallel to each other. So that literally means, so we know the line AB, that's this line, we know that equation, and we know that DC is parallel. So these two are parallel. Oops, and there I go again, rubbish line. These two are parallel. Right. Okay, so the first question, first part of the question, wants you to find the gradient of AB. So the gradient is denoted M. So what is M? We know that the general equation of a line of a straight line is y equals mx plus c. This being the gradient, this being a constant. So this question is nothing more complicated than manipulating this to look like this. So let's go 3y equals 14 minus 2x, and I've literally just minus the 2x onto that side there. And then y equals 14 over 3 minus 2 over 3x. Therefore, the gradient is 2 over 3, minus 2 over 3. And it's worth writing that down just so to like kind of confirm to the examiner that you understand that. I mean, these questions really try and kind of knock you off with the minuses and the pluses, but I mean, it's a negative gradient, so it's going to be negative, like it's sloping downwards. That's probably not the most technical thing to say, but it's a negative gradient, so I think sometimes you've just got to like be a bit, these are the silly mistakes that can really catch you out, basically. So, on to the next question. B. Right, so it's giving you that the point D has coordinates 3, 7. So find the equation, part I, is find the equation of the line DC. This is basically just testing. So this question is just testing that you know that that is the equation of a straight line. This question is testing whether you know how to use the formula y minus y1 equals mx minus x1. That's literally all it's testing, because so we have D, right? We have the coordinates of D. This is x and this is y. And we have that DC and AB are parallel, and generally speaking, they don't tell you things like that in exams just for fun. Like, they probably want you to use that at some point, particularly on these questions where they're talking about gradients, because that therefore means the gradient of DC is the same as the gradient of AB. if that's not obvious, then just write in the comments and I'll explain in more detail, but I mean, most of you should understand that. Right, okay, so we know already that m is minus 2 over 3, the same as the gradient for AB, right? And we know that our y1 value is 7 and our x1 value is 3. So literally you just need to plug it into this equation. So we have y minus 7 equals minus 2 over 3, x minus 3. And literally, it just what, like, AQA, they're not looking for you to, like, write it out in some fancy way. They literally just want you to write it like that. And you also get a method mark if you write down whatever gradient. Say you get this gradient wrong, but then you write it down here. In this equation, you get a method mark. Okay. So, part 2, II of B, is telling you the angle BAD is a right angle. So generally speaking, if they give you an angle BAD, bad, it's annoying that they use this notation like DC, BAD, like that's a line, this is an angle. And with an angle, the point, like I'm not using very technical terms here, but like the way I always thought of it was the point of the angle is the middle letter, so A. So we've got BAD. So this is the angle, and it's a right angle. That, well, let's just read the rest of the question. Find the equation for the line AD, giving your answer in mx plus ny plus p equals 0. And it's saying where m, n, and p are all integers. Right. For a start, this part, don't let this scare you. This basically just means that they want you to do this, but then just manipulate it to look like this, with n, m, and p being integers. Integers just literally means whole number. So, for example, like don't overcomplicate that in your head. Like, for example, 1 over 2 isn't an integer because it's not a whole number. It's half a number. So an integer is a number like 2 or 4 or 1 million is even an integer. Okay, so basically it's just asking you to find the line of an equation again, and we have already that we have the point D already. So D is a point on this line, right? So we already had that point. So we know that D is 3, 7. The coordinates of D are 3, 7. So all we need, basically, to fulfill this equation is to book it out, is the gradient. Now, this question is just testing that you know that if a line, so this being at a right angle basically means it's perpendicular to AB, right? And you know in the AQA syllabus, it says that if two lines are perpendicular to one another, then if you times their gradients together, they equal -1. Right, okay, so that basically means if you times the gradient of AB with the gradient of the line AD, which you're looking for, this is what you want. This is like this M2 here, this is exactly what you want. And it's always good to write these little formulas out as well because it shows that you understand. So this equals -1, sorry. This equals -1. So we know that the equation of AB, the gradient of AB, is -2/3. So if you just plug this in, times M2 equals -1, then literally M2 equals 3/2. So we know the gradient of AD is 3/2, and we know that the point D is 3, 7. So literally just using this equation again, y minus y1 equals mx minus x1, we can plug all of this in. So y minus 7 equals 3/2 x minus 3. And they want you to manipulate that to look like this with these constants being integers. Not constants, sorry, these m, n, and p all being integers. So let's just do that. Y minus 7 equals 3 over 2x minus 9 over 2. Let's times the whole thing by 2 to make the whole thing integers. 2y minus 14 equals 3x minus 9. And then let's put all of this on one side of the equation. So we get 3x minus 2y plus 5. And that's the answer. That's all they're looking for. And that's another 4 marks. So just this is 2 marks, this is 2 marks, and this is 4 marks. Okay, so question C gives you, in the question, it gives you that the line BC has equation 5y minus x equals 6, and it wants you to find the coordinates of B. So you just kind of need to use what you know at this point. Like, you know this line now, it's just giving you this line, and you know the line AB because he gave you that at the start, and you want to find what the coordinates of B are. Now these two lines intersect, so that means that if you do simultaneous equations on the line, so this is the line AB, 2x plus 3y equals 14, then you find that x equals 4 and y equals 2. I won't go through that simultaneous equation because you should all be able to do that. If you want me to, I can, just ask me to in the comments, but that should be relatively obvious, and that's 3 marks. So in total you've got 11 marks there. I think really what this question is doing is it's kind of testing whether you know that that is the equation of a straight line. It's testing that whether you know that this is how you find, that this formula is how you find the equation of a line if you know the gradient and if you know 1 point on it. And it's testing if you know whether if you times 2 perpendicular gradients with each other they equal -1. And also this is like kind of the top, kind of the people that kind of are going to get the top marks. They're going to do this because it just takes a bit more. I mean, they can't really. This kind of thing only comes with practice, really. Like knowing how to these kind of part C's of these questions. They're just for the people that kind of want the A's, the A stars, kind of thinking on your feet, and that just literally comes with time and practice, and just really like kind of working through the question, thinking about what they've given you, and using it to your advantage. So thank you for watching anyway. I hope this was helpful for you. I'm going to link in the description box below a similar question from an AQA past paper, and also don't forget to kind of visit the website for some extra material, and good luck with revising.